Okay, here you see a schematic of a typical job shop or a process layout. You can see that on one side you have all the lathes, that is the turning department or the lathe department. You have a department for milling, you have a department for drilling, you have a department for grinding, painting, assembly, on and on. So here you can see those arrows going back and forth. What that depicts is the flow of products. So here you can pretty much produce any product you want, which require a set or a subset of activities or processes that you are capable of. So you may require one product that needs to be turned, milled, grinded, inspected, and out. Another product may have to be drilled, grinded, painted, out. You can do any one of these. And if you look at this, the layout is based on different processes that you are capable of. You can even look at a supermarket to be like a process layout, because there is a dedicated area for produce. There is a dedicated area for appliances, dedicated area for men's clothes. A department store is a process layout. A typical cafeteria in a university has a process layout where you may have one place where you get pizza, another place where you get subs and sandwiches, another place where you may have a Chinese counter. So that is a process layout. If a student wants to go and get some Chinese and then go and get some fries, he or she needs to go to those two dedicated areas or processes. So a job shop is where every area is dedicated to a particular process. Now look at an example of an assembly line, an actual shot of an assembly line, where you have multiple cars being produced there, all in line, in one line. Unlike in a job shop, all the products, every unit that you're producing goes through the same sequence of steps. In this case, you have robotic arms doing some assembly, and maybe in some cases some welding, some kind of painting also. But in many assembly lines, you may not have automation like you see in this picture. You may have people, workers, or a combination of workers and robots doing the assembly. But the key here is all the products, all the units are going through the same sequence of steps, unlike in a job shop. And we'll understand this in more detail in a few minutes. And an assembly line is typically used in most automobile production, laptops, and like I said, even some of the aircrafts. Now let us understand in more detail the difference between a process and a product layout. If you look at the process layout, you typically produce customized products there. These are not products that you will make to stock. You typically make to order. Whereas in the product layout, you typically produce standardized products, make to stock. In a process layout, you have functional grouping of activities. That is, there is a dedicated area for grinding, welding, so on. A dedicated area for Chinese food, for pizza, for subs. Whereas in the product layout, there is a sequential arrangement of activities. That also we saw in the car assembly line. Let me give another simple example. A McDonald's drive-up service. If you go in your car and you want to buy something in McDonald's, you have to go through the same sequence of steps. Order the food, pay the money in the second window, third window, you pick up your food. It doesn't matter whether you're buying 5 burgers and nuggets and fries, or you're just picking up 1 drink. You have to go through this set of activities. Each product in the job shop or the process layout is different. An assembly line. And the routing required to make that product analogy of an assembly line. Whereas, as I already have mentioned, It's a fixed path or fixed route in an assembly line. A process layout is acceptable, is required when the demand is low. You cannot afford to have an assembly line when you have a very low demand and if the demand is fluctuating a lot. Whereas once you know that you have a high demand and stable demand, you can justify having a product layout or an assembly line. In a process facility, the kind of equipment will be more general purpose. Again, because you're making different products. Whereas in an assembly line, it is going to be special purpose equipment specially made for that particular product. When you change the product a lot, like in a new kind of car, the design is completely different, the process is different, then you have to change the special purpose equipment. In a process layout, the fixed costs are low, but the variable costs are high. On the other hand, in the product layout, the fixed costs are high because you are using special purpose equipment. The initial investment will be high, but the advantage is the variable costs are low. That is what made Henry Ford's Model T so popular. Henry Ford was able to pay the highest wages during his time and still make the least expensive vehicle. The single most important reason for that was the variable costs were low. But of course, the product line was only one. He did not make different kinds of products. The last bullet, the labor skills required in a process layout are much higher and much varied as compared to the product layout, where most of the assembly line workers are working on one workstation and they're focusing on one thing. It is monotonous, unfortunately, in most assembly lines, but the skill level required is not as high as in a process layout. In a process kind of layout or a job shop, the work in process inventory is higher. You have a lot of inventory within the facility. Whereas in a product layout, you design the layout in such a way, you balance the assembly line in such a way that the work in process inventory is 0 to very little. Okay, you don't want to have work in process inventory or bottlenecks. Scheduling, which is another chapter in our course, where we discuss about scheduling. In a job shop, scheduling becomes extremely important. Who is going to work where, in what sequence, and so on. Whereas in a product layout, scheduling is routine. Like I said, the same assembly line workers are going to work at the same workstation doing the same thing whenever the next product comes in. So it is relatively routine and easier. But there are other complex issues in a product layout. Estimating the cost to produce each product in a process layout can be a little more involved, a little more difficult than in a product layout. The most important objective in a process layout is where to locate each of the machines so that material handling is minimized, so that it makes logical sense to put two different kinds of processes or machines or work centers right next to each other. How do you do that? That is the single most important consideration. Whereas if you look at the product layout, you have no choice of where to put the machines because they have to be in the sequence in which that particular product requires those machines or processes. What is more important there is to balance the assembly line, which is the next topic we'll discuss. In a process layout, you want to minimize the material handling, whereas in the product layout, like I said, balancing the assembly line is the same as equalizing work at each station. You don't want one workstation to take 10 minutes to do all the things that are required, whereas the next workstation requires only 8 minutes. And you don't want the reverse either. You don't want the first workstation to take 8 minutes, the second one to take 10 minutes. As far as possible, you want all the work centers to take the same amount of time in theory. In practice, almost the same amount of time so that it is all balanced. It is synchronous. Finally, what is the real strength of an assembly line? Efficiency. The product layout is known for efficiency. That is the reason that people want to have an assembly line when they have high demand, stable demand. And what is the single most important advantage of a process layout or a job shop? It's the flexibility. Job shops are not efficient, but highly flexible, whereas product layouts are highly efficient, but inflexible. I hope you understand now the difference between a job shop / process layout and a product layout / assembly line. Let's talk about designing a job shop. There are two tools that you use in designing a job shop. If you recall, in designing a job shop, the most important thing is the optimal or the ideal location of machines or processes within a facility, and then minimize the material handling between each of these machines or processes or work centers. We use two tools. On the two tools, one tool is the from-to chart, very basic from-to chart, where if you look at the picture here, it is showing how many times you are going to have movement between one workstation or machine to another workstation or machine. So if you look at this from lathe to the drilling area, you see that there are 32 units being moved, or there are 32 times you move something, or 32 pounds or kilograms you're moving. So what you're doing in this chart is telling the software that is used to do the layout how many times you're moving things from one facility, one work center, one machine to each of the others. So that is the simple tool. So if you look at this, you see that there are areas for raw material, lathe, drilling, milling, inspection, packaging, finished goods, and on the columns also you have the exact same processes. And what the chart is telling is the amount of movement that is occurring between each area to each of the other areas. So this is the first step a person who is involved in designing the layout has to provide the software. The second one is called a relationship chart or a Muther's grid. This is again a very simple tool. What it does is it tells what is the need or what is the reason for proximity between any two areas, or the need for proximity or the lack of need for proximity. So if you look at this, you see the areas: production, offices, stockroom, shipping and receiving, locker room, tool room. So this is a simple example. So you have these 6 different areas. And what the Muther's grid is telling is which of these need to be close to each other. So if you look at the key, A is absolutely necessary. So look at that. It is absolutely necessary. Look at where A is. You have for production and stockroom. So it is absolutely necessary that the production and the stockroom are right next to each other. Then if you look at especially important, E. So you look at production and locker room. They're especially important. U is unimportant. It is unimportant to have shipping and receiving right next to the locker room. Okay? Now look at X, undesirable. You don't want to have the offices right next to the locker room. So whether you're talking about a huge office or a process kind of layout, a relationship chart is very important. What do you want to have next to each other, and what don't you want to have next to each other? And you can create your own legend or key. And here you have 6 different components to your key, absolutely necessary to undesirable. You can even put weights. You can say you want to give a weight of 10 for the production to stay next to stock room. You want to give a weight of -50 to have the CEO's office right next to the production facility, if you don't want to have that to happen. Because what you're going to do now is take the from-to chart and the relationship chart and feed it to some sophisticated computer layout programs today. And I've just mentioned one of them, CRAFT, which is computerized relative allocation of facilities technique. And what that software does is takes into consideration the from-to chart, how much material handling is occurring from each area to each other area. And then it takes into account the relationship chart, which tells you what is desirable and what is not desirable, what is important, what is not important to stay next to each other or stay in close proximity to each other. And then it'll give you alternate solutions of layout. And you can use that, tweak it a little bit, change the weights if you want some changes in the layout. And of course, you can overrule the software and make changes that you think are important. So that is how a process layout or a job shop layout is completed. Product layout. You see an example here in this picture of an old assembly line. It's a quick illustration of an assembly line. You see different number of workers working on each workstation. So you see here there's workstation 1, 2, 3, 4, so on. You have multiple workstations there. Another illustration of a modern assembly line of a Boeing 737, I believe. And you see that, again, this is a workstation, this is a workstation, this is a workstation, and you see at each stage there are aircrafts on which different workers are completing different operations or processes. So this is the most completed plane in this picture, and this is the least completed one in this picture. And the assembly line is flowing this way. This is the upstream, this is downstream. The key here now, as we will discuss, whether it is this or this, either way, you will have to make sure the time that is taken by all these people to complete the tasks in this particular workstation is the same or almost the same as the time taken by all these people here to complete the tasks at this workstation or this or this or any one of these. That is called a smooth assembly line, a balanced assembly line, a synchronous assembly lines. It is like a symphony. Everybody is making sure that their part is completed. And guess what? The movement of parts or the movement of aircrafts in this example will occur from here to here, from here to here, here to here at exactly the same time. So for in this example, it may take a week at each workstation here or each hangar for all the operations to be completed. In this case, it may be 15 minutes at each workstation. Or it may be only 30 seconds in some fast-paced assembly lines at each workstation. The key is to figure out whether it is 30 seconds, 15 minutes, 1 week, and to make sure that every workstation takes approximately the same time. So what tasks do we assign to each workstation and in what sequence so that each workstation is taking the same amount of time? That is a balanced assembly line.